Hello. Hey, everyone. Welcome to our decentralized mining panel. I've got a really great group of people here today. I'm very excited to be presenting this at SatsConf. So I think to start off, I'm going to go ahead and let my panelists introduce themselves to you. I'm Nifty. I'll start. I'm NiftyNei. I run conferences and do Bitcoin development on the Lightning side, and love doing Bitcoin education at Base 58. Let's go ahead and start with Plebhash. Do you want to introduce yourselves? Tell us a little bit about what project you work on as well.
Hello. Sure, yeah. I go by the Plebhash name online. I'm currently working on Stratum V2 as a Spire grantee. It's a project that aims to improve mining decentralization. Yeah, that's it.
Improving mining decentralization with Stratum V2. Very good. Thanks, Plebhash. Great. Scott, what about yourself?
That's what we need to do. This improving mining decentralization is an important topic. My name's Scott. I'm the instigator of the BitAxe project, which it's kind of crazy. The BitAxe is the first open source ASIC Bitcoin miner ever. And we've had ASIC Bitcoin miners for over a decade, and the BitAxe is the first one. I guess for those that aren't familiar, it's a small miner that you can run at home. It's got a low hash rate, but we use the chips out of the S21 Pro and the Ant miner line of miners. But the cool thing is that it's all been reverse engineered and documented, and it's all published open source. So while I don't manufacture or sell them, tons of people all around the world do, with the idea of getting these things out there so that people can run them and play around, understand how mining works, while also helping to decentralize mining and maybe get lucky in the lottery.
So it's a mining project where you can have a miner at your house.
Yeah, it's a mining hardware project. And it's like actual people, not like industrial facilities, can have them.
Can make it, which is so cool, yeah. Cool. And if you wanted to, anyone could go out and find the information and the open source stuff and build it themselves at home. Is that the idea?
Yeah, it's not going to lie, it's difficult. If you want to build one yourself, I have instructions on how to do it. It's a pretty complicated circuit, but people have done it. People with no electronics experience have built it.
Well, the guy who's selling them here at the conference, he soldered them at his house. Like, he did it by hand.
Yeah, you can do it. It's possible. I'm not going to say it's easy, but with some careful study, I think mere mortals can solder it. And I think that's a superpower in itself, being able to build electronics and not just rely on someone else to build it. And bringing that to Bitcoin and to Bitcoin mining specifically, which has gone very proprietary and closed source, to sort of open that up to anyone who's interested is the goal here.
Cool. I want to come back to this idea about centralized mining versus decentralized mining. But first, let's hear from Gloria. Do you want to introduce yourself? Tell us what you're working on.
Sure. Hi, I'm Gloria. Really happy to be here. I'm one of the maintainers of Bitcoin Core, and I focus a lot on mempool and transaction relay logic, which is relevant to decentralization and mining. If you think of the peer-to-peer, like gossip and mempool logic as like the distributed way to bid for block space. And where you're bidding based on fees, and you submit through this kind of decentralized network to miners in the most open way possible. So in that sense, it should be censorship resistant, it should be private, and it should be decentralized, as opposed to, say, if you have a direct submission pathway to a miner. So I think a lot about the efficiency of fee bumping, the ability to update your bid to the miners for block space, because if we have inefficiencies in our decentralized way of bidding to miners, then centralized services will take over, and that's really bad for the network.
That is really bad.
So yeah, let's talk about this idea of, the name of this panel is decentralized mining, right? It sounds like that's something like, why isn't mining decentralized today? That seems like a given, right? Like Bitcoin was built as a decentralized system. Why is it that we're having to talk about mining decentralization in the way that we are? Like, what about current mining today makes it centralized?
Well, it it boils down to a lot to incentives. It when Bitcoin started, everyone was solo mining. Everyone was a solo miner, and then people started figuring out ways to get more hash rate out of silicon. So GPUs, FPGAs, then ASICs, and then hash power started to grow, and then there were way too many people with decent hash power mining at the same time, and then it starts to get hard to do math on your electricity bill versus your Satoshi's income, because the Satoshi income is bound to a statistical concept of variance, right? If you have a hash rate and you compare this hash rate to the network hash rate, you know that on average you're going to get a certain amount of sats, but there's variance there, and you could have unlucky days, and then when the unlucky days come, you still have your fiat bills to pay. So people started coming up with this idea of pooled mining, which allows you to make variance a bit smaller. So if the pooled hash rate is large enough, then you can get a little bit more certainty on your average income. And that helped things for a while. But then miners started getting kind of spoiled with this, and then they started demanding a flat income, right? And pools became a business. Pools became corporations. So pools started offering flat payouts. And for that to happen, pools need to have very deep balance sheets, because pools are going to have unlucky days. And then the pool started assembling behind closed doors, in a way that larger pools that have more predictable income will bail out smaller pools whenever they don't have enough sats to pay the miners whatever they promised. And that's where centralization starts, and also templates, but I guess we're going to get there.
I just wanted to touch on the hardware side of it too. So this centralization of pools is a really big deal. Obviously, they pick the transactions that are included, but we also have in mining, we have the hardware is a very important part of it, which is also the manufacture and design of that is also very centralized. And I think that started to happen right around the time ASIC mining started. Because we were before that, Satoshi was using CPUs and GPUs, and then people were messing with FPGAs, which are just general purpose hardware that people can get and reconfigure. And I think back then, miners were sharing designs and collaborating on how to make this work faster, better. But then ASICs came along, which refers to the chip, but it's a very, very resource capital intensive project to make a chip, like millions of dollars to even think about starting to do it. And I think that once companies were laying these huge outlays, huge teams of engineers to develop it, it really, I think they felt the hurt, they felt the pain of how expensive these are, and it became this competition. Like, there's no way I would tell a competitor what I'm doing or share information with them, because there's so much on the line. And I think that the ASIC generation of miners started this secretive, proprietary thought process around mining. And it's also a really hard business manufacturing these things. And so we sort of coalesced onto a very centralized group of, I don't know what the percentages are, but I think most hardware is made by Bitmain by a large margin. And so we're left with just them. They've got such a big head start over the rest of the industry. They're so far ahead that the majority of hash rate comes from their machines and their firmware and everything that they set up.
And their pool.
And their pool. They also run a pool. That's just great.
So just to kind of make sure that we're all following along, like an ASIC is a special computer. So like back in the day when Bitcoin started, anyone could take their laptop and mine, right? And you could have a chance of winning a block, right? Because it's kind of like participating in a lottery, right? When you run a Bitcoin miner, you're like participating in this big lottery. And depending on how long you run and how other many people are running computers, kind of that predicts how much Bitcoin or how many times you should win, right? Kind of like a raffle, is that?
Yeah, that's exactly right. I mean, in that way, you're competing with the others, because Bitcoin mining has this concept of the difficulty adjustment. To keep block cadence at roughly 10 minutes, we adjust the difficulty to account for new miners coming online. And so, the more people that are doing it, the harder it will be for any specific individual.
Right. So what happened again? So it used to be everyone that was running a Bitcoin node on their computer could also mine, but today you can't really do that, right?
You can, actually. I mean, you can run the mining algorithm on your CPU, but the thing is, because the difficulty is adjusted so high over the years, it's just purely an educational thing. You can't expect to have any realistic chance of solving a block, or if you're mining with a pool, of getting any sort of payout whatsoever.
So mining kind of evolved in the early days from anyone with a computer to now it's like, okay, you have to have this special built custom machine that all it really is good at is hashing first, trying to find Bitcoin blocks, right? And the only people who make those are these big company called Bitmain in China. And so if you want to be mining Bitcoin, you need to find one of these machines and buy it from this specialized manufacturer, because otherwise you don't have a chance in the world in winning a block, right? Is that a good picture? Okay.
Yeah. That's unfortunately totally exactly right.
Have any of you tried to buy miners from you guys before the BitAxe project? How would someone go about getting one of these ASICs? Have anyone tried to do this before?
There's sellers. You can't go to Bitmain directly. They kind of only deal with the really big accounts. But there's resellers where you can go and buy one. So it's totally possible. I think it's sort of a huge ask for someone who's interested in getting into mining, though, to do it.
Yeah. So that's not very decentralized, right? It's not very accessible. It's not something that most people could go out and start mining these days. It's where would you get a BitAxe machine from, right? And then once you get a machine, it's okay, do you have enough power for it? Is it can you afford to run it? Is it going to keep running? What if it breaks? That kind of thing, right? Because you said, these are proprietary machines, right? So it kind of paints maybe a good picture of the way mining is today. Is there anything maybe I'm leaving out about decentralization around hardware?
I think that's right. I mean, these machines, I think people who haven't done it don't realize how ridiculously impractical it is to run an industrial mining machine at your house. They're 3,000 to 4,000 watts, require industrial power, right? You're not going to just plug this into the normal outlet. It's specifically maybe you have an outlet for your hot water heater or your stove or something. But even if you're able to plug it in and turn it on, it's incredibly loud and incredibly hot.
And it's going to melt down the wires if you don't.
It's going to what?
It's going to melt down the wires if you don't change them.
Yeah, if you don't have adequate wiring for it, it can absolutely melt it, trip your breakers, melt your wires. I mean, fires have been started. But let's just say people who've gone through the trouble, okay, I get an electrician to come out, wire it all up. And then that's when the pain starts, because this thing is not meant for home use. It's meant for industrial use. Super loud. I did this exactly the same thing myself. I had free power at my office. I'm like, great, I'm going to be a miner. I got free power. Plug this thing in. I was like, wait a second. I can't actually be in my office when this thing is running. So they're really difficult to use. This is where home miners come in.
Cool. So one of the problems with mining right now, at least being centralized, is access to hardware, which is where your project comes in with the BitAxe. You've made it so that now anyone who's accessed can either buy one from a friend who's building them. Sounds like you can buy a BitAxe here at the conference, and you can take it home and plug it in, and it's not as loud. It'll run on home power systems. Is there anything else about the BitAxe that makes it really nice for being at home?
Where to get one? So we have an interesting distribution model. People aren't familiar with open source hardware. It's kind of a new concept. And so BitAxe isn't a company. It's an open source project. I don't make them. I don't sell them. I do have a list of people who do sell them. If you go to bitaxe.org, I have a list of people all around the world that manufacture and sell them. I want people to know that this, we haven't solved any crazy efficiency breakthroughs, right? because it's so quiet and uses so little power and isn't as hot is because it's mining at a way lower hash rate than these machines. So that translates into a lower payout on a pool or dramatically worse odds if you're solo mining. So I don't want to, this isn't like the cheap get rich quick thing. We haven't figured out how to do that. But it is something that you can do and mess around with.
So it makes it accessible.
Yes.
How much faster is a BitAxe? So we started kind of the conversation talking about, and sorry guys, we'll get to the mempool template stuff for the second half of the talk. But we started with everyone being able to run mining at home on their CPU. And we went to, okay, now these are specialized machines that you have to find one and then totally build its special little environment that it can run in, like an industrial mining machine. And now we've got these open source, smaller powered devices that we can run at home. How much faster is this home one than running it on your computer, if that makes sense?
It's like 10 million times faster.
Oh, wow. Okay.
Okay, yeah, it's like ASICs are magic. They can hash incredibly fast. And even though we only have one, unlike an industrial machine will have 200 plus chips, they still are magic. It's like 10 million times faster than a CPU.
Okay, cool. So you're still getting like super better performance than on a CPU, but you're still you're competitive, not really competitive even.
Yeah, it turns out that people have huge warehouses full of these miners, and they are, profitable, competitive with just one. You get what you pay for.
But like a BitAxe compared to CPU is like 10 million times better. Okay, cool. That's cool. All right. So that's a lot. So I think we've kind of deep dive into the centralization and how open sourcing the hardware is helping make running miners at home and more people able to participate in this global lottery system. Now let's talk a little bit more about the other part of centralization around the mempool and the block templates, right? So Plebhash, do you want to maybe talk a little bit more around like how Stratum, like maybe what that problem is and how Stratum plays into it?
Sure. The problem is like what I said earlier, the pools are now like starting to assemble into this crazy pyramid scheme where the big pool is bailing out the smaller pools. The big pool is like, okay, if I'm gonna bail you out, you kind of have to use. You're going to give whatever work to your miners as I'm giving. There's more nuance, but if you have to summarize it, it's kind of like that. But also, this is a design problem that pools, in the inception of pools, nobody really cared about template decentralization. So it just, in the original design of the Stratum protocol for pooled mining, it was just a design assumption that the pool is going to choose the transactions that are going to go into the block. And it seemed like a simple design. It seemed like a simple way to approach the problem. And then people didn't really think about the consequences. But now that we have pools that are large corporations that are traded against, and they're bound to compliance standards with the government, and so now we have this problem where the government could come to these companies and say, okay, you're not allowed to include a certain kind of transaction in the blocks. And if they do that with enough pools, we have censorship on Bitcoin. And so that's a big problem. But it doesn't have to exist. It was just on the first version of Stratum, and when miners started to assemble into pools, they just didn't think about this, and they made a bad design decision. But there's nothing inherently baked into the Bitcoin protocol primitives that makes it doesn't have to continue this way. So Stratum v2 allows for miners to continue doing pooled mining, which means that they're gonna aggregate their hash rate, and they're gonna agree on some Coinbase payout scheme, and then but each miner decides which transactions go into a block, and that, and now if the government wants to shut down and the government wants to control block space, now they have a lot more targets to chase and prosecute and try to enforce. So it's a step that we need to take in terms of not making all the decision making around templates centralized on pools.
Sorry. Yeah, I'll just add on to that. It's very important that there are a lot of block template producers, right? We don't want to have, like in Ethereum, for example, just a few producers that decide what transactions go in, or pool managers or whatever. And so then it becomes really important to make it accessible to, from the available pool of transactions that have been broadcast that are, consensus valid and can go into your blocks, choosing the most incentive compatible block, like most incentive compatible set of transactions to put in your block. And so that...
So basically how much will get them the most money?
Yes.
Okay.
Yes, that's what I mean. Yeah, so if it is extremely complicated to look at this mempool and figure out what is the most profitable block I can build, then you'll end up with these like third-party services that then do all of the block template building for you, which is why, instead, I think we're doing pretty good about this, although there are a lot of improvements that we can make. Bitcoin Core, the open source, implementation of a block template producer is, as far as we know, pretty close to optimal. Right, it's close, right, and we're trying to make it closer. And that's really important because even if you have the ability with Stratum v2 for everybody to choose their own templates, if not everybody is able to get the most incentive compatible transactions, then they're going to want to choose, a central authority again to build those blocks for them.
So just to maybe summarize a little bit, one thing that the pools do is they look through all the transactions that are available and want to be mined, and they get to pick out which of those will end up in the next block, right? And that's what we mean by building a block template, right? So it's really about, I have all these transactions that want to happen on Bitcoin. I'm going to put a template or a set of those together that I'm going to include in the next block, right? So they have a lot of decision-making power around what actually ends up being confirmed as a transaction. So that's what we're talking about with block templates. And then the incentive compatible part of that is basically saying when they pick out all those transactions out of the possible ones that want to get in the next block, the biggest incentive is going to be the ones that pay them the most money, right? So there's default software that you've worked on in Bitcoin Core, and that's what helps pick out, okay, out of all the available transactions that we know about, these are the ones that as a miner you should include in your next block, right? What kinds of projects are you guys working on? We only have like a couple more minutes, but what kinds of projects are you guys working on to make sure that that set of transactions that Bitcoin Core, the open source implementation, gives people like these transactions we know are going to make you the most money, and there's no other set of transactions that will earn you more money, right? It's kind of the goal, right?
Sure, yeah. I'll name two projects. One is a very big one that maybe some of you have heard of called Cluster Mempool, which essentially re-architects the entire data structure to make it a lot more efficient and more optimal. The kind of linearizations of transactions that you end up with, the block templates that you end up with, as well as kind of assessing, let's say you have transactions in your mempool and someone broadcasts a replacement either on purpose or malicious, assessing whether this new transaction, it results in a more incentive compatible, more profitable mempool than keeping the existing one. That question is actually really difficult to answer, as well as like when your mempool fills up to your maximum memory capacity, deciding which transactions to drop. Like these are all incentive compatibility questions that ultimately lead to how profitable your blocks are going to be as a miner. And cluster mempool is again like a very big change to the fundamental architecture of mempool to make these questions of incentive compatibility easier to answer. And then the second project that I'll mention centers around, I've done a lot of work on pitting attacks. So the central idea is we have all these these trade-offs between we want the most incentive-compatible transactions in our mempool, but we also want to make sure that running a node and participating in transaction relay and keeping a mempool is actually reasonable for a laptop or user or a Raspberry Pi node runner to do. And so that's all about denial of service protection. It's like minimizing the amount of resources, or at least putting a hard cap on the memory and computation and bandwidth that transaction relay and validation take up. And these result in very unfortunate limitations that can result in, for example, not accepting replacement that is more incentive compatible to mine, but in a really dumb way. And so pinning attacks, I'll define pinning attacks again as like if you can hit these edge cases on purpose, that means you can censor transactions in the worst case. But in the best case, like even in the non-malicious scenarios, it means that like miners are losing out on revenue because of like dumb edge cases. And so like a few projects that I worked on that are in the latest release of Bitcoin Core include truck transactions, also known as V3 transaction relay, also known as BIP431, which is directly trying to address pinning attacks as well as make replacement RBF logic a lot better and not be susceptible to these problems.
Cool. Thanks, Gloria. Unfortunately, I think we have run out of time, but do we have are there any things that you guys would say, like a quick short thing of where people should go to find more about your project or mining decentralization? Gloria, do you have a quick? Let's start with Plebhash. Do you have a quick thing people could look at for Stratum V2?
For Stratum V2, you should go to stratumprotocol.org. You have like all the information about the protocol there. There's a getting started guide. If you want to play around with the code base, the specification is there. Stratum V2 has a spec. Datum does not.
Cool. Scott, what about for BitAx?
You can go to bitax.org. It's all there, community links, design files. Jump right in. Like, this is totally something you can do and play around with and have fun.
The best place to start would be BIP431, topologically restricted until confirmation transactions. And I would also recommend the Bitcoin Optech newsletter in general, but I also wrote a 10-week series called Waiting for Confirmation. It'll be in the blogs page on the website, and it talks all about mempool policy, pinning, why miner decentralization is relevant to this, etc.
Cool. Thanks so much, y'all, and thank you.
Thank you.